What is protein and why is it important for your body? What's up, everyone? I'm Hamza Aziz, the producer of the Talking with Dogs podcast. Protein is more than just for muscle building. We're breaking down why it's essential for your body and how to make sure you're getting enough of it.
Protein. This is all about protein, what it is, how it works, what we need it for. Really?
Sorry.
Welcome to Talking with Docs. I'm Dr. Brad Weaning.
I'm Dr. Paul Zalzo.
Welcome to our channel. If you're interested, please leave a comment, subscribe, like it. Check out our podcast that we recently launched to just share information to help people live better, healthier lives.
There may be some of you that are new to the channel because we are getting more and more subscriptions.
Yes.
We're trying to get to 1 million, so please tell everybody you know. We're almost there.
There you go.
But if you're new, this is called Talking with Docs, where we're a couple of docs that talk. It's a creative title for our channel.
Yeah.
So it's Talking with Docs. It's not that creative. Basically, we find topics, we discuss them.
Yep.
Many of you leave comments about them.
It often drives the content, for sure.
Some of our comments inform the next videos.
Right.
And help each other, of course, too.
Okay.
So today's topic is protein. This is a very popular and inflammatory topic, it seems.
And people talk about it almost like it's a food, like you go to the grocery store to get protein.
Yeah.
You don't. You go to the grocery store to get food.
Food,
but
which
I think,
has protein
which has protein
in it.
in it. But what's happened, I feel like we've reduced our food and our diets to macronutrients rather than the actual foods themselves.
Right.
So let's start at the very beginning. So
A
there
very good place to start.
it's usually where you start. So there are 3 macronutrients. There's fat, there are carbohydrates, and there are protein.
And shocker, you need them all.
Yes.
That's why they're called macronutrients.
Yeah, I would say some people would argue, depending on your diet, that you need carbohydrates and fats very, very minimally.
Mm-hmm.
I don't believe that, but some people would say that. But yeah, so fats, primarily an energy source.
And how we store energy, and
Yes.
how animals store energy.
Exactly.
In
Same,
fats.
same for carbohydrates. It's a short-term energy source, and then it can be later converted into fat. And interestingly, fat, when you eat fat, you can convert it to other fat, like your own body fat, at an efficiency rate of about 98%.
That's pretty efficient.
So it's very
for a
easy
machine.
for our bodies to take fat and make it fat. This may be why fat in your diet can contribute to obesity.
And carbohydrates we get from the primary producers, right, which are plants, because they can take the sun's energy and
Yep.
convert it into a chemical energy like glucose that we can use,
I love that.
right? And we can't do it because we
do it.
can't photosynthesize yet.
We don't have solar panels in
One
our
day.
skin.
You're on your way with your vegan diet. I say another 3 years, you'll be able to just go
Maybe.
and photosynthesize, but the majority of us cannot. So we have to consume primary producers in order to get that
Right, and so
chemical energy that they got from the sun.
yeah, so carbohydrates we can store. We use it in the short term, but we also can store it in something called glycogen that lives in our liver and in our muscle. But the amount of actually is quite limited. It's about a kilogram. Whereas fat, we can store almost an unlimited amount because of our ability of our skin to stretch and our organs to tolerate. So about a kilogram of carbohydrates can be stored in something called glycogen. And this is the stuff that's used during more extensive or intense exercise. And when you hit a wall, like a marathoner at like the 20-mile mark, they run out of glycogen and then they're relying on fat again.
Okay, put the fries in the bag. Nobody ordered a yap test here. We want to know about protein.
Okay, so protein.
That's what this topic
So protein is the third macronutrient.
So you're just setting the landscape
Setting
of
the-
where
paint
protein
the picture.
lives in this thing. Fats, carbs, protein.
Right, so protein is used for things of structure.
Yes.
So your muscles, your bones, your skin, your hair. It's also used for neurotransmitters and hormones, but mostly for our structure. So things that make us who we are.
Protein is a brilliant type of molecule because it's three-dimensional. It
is.
folds and bends upon itself.
Yes.
And those are the things that give it its function.
Right.
And one of the main differences between chemical differences
Yes.
between protein
Yeah.
and other macronutrients like fats
Yes.
and carbs
Yes.
is the presence of nitrogen.
Right,
Nitrogen, and that's one of the factors that helps it have such strong structure.
right. So protein is made up of amino acids.
Yes.
And what an amino acid is, it's a carbon, central carbon, with a hydrogen molecule,
yeah.
a carboxyl group,
Yeah.
an amine group, so an NH2 group.
And that's the difference.
That's what makes it unique.
Without the amine group, it's just like carbs, it's just like fats. They're just C's and O's and H's, carbons, oxygen, hydrogen in big chains. But now when you throw in that NH2, that
Right.
amine group, that's what makes it now into the class of amino acid.
And then the fourth little thing for the amino acids is what's called the side chain, and that's what makes them unique. We're going to talk about that in a second. Well, let's just go back to protein. So when you eat
I
protein,
think we should go back to amino acids because that's what makes the protein.
we're gonna. But when we eat protein, though, we can't store protein. It is
Not
not
as protein,
You
no.
cannot store protein as protein, and that's the interesting part about amino acids. When you eat excess protein, it can be converted to fat. It's very inefficient in about the 66 to 70% range. This is sometimes why high protein diets actually reduce or present as less fat,
Right.
because you lose 30% or so to heat.
Yeah, fine, protein. And remember, it's that nitrogen group. Fun fact. Do you know what the most abundant gas in the air is?
Nitrogen?
Nitrogen.
78, 79%,
By
I think, right?
a long shot. Isn't that cool? And it just
Yeah.
happens that we really need nitrogen to live.
It is.
The nitrogen cycle. But nitrogen in the gas is very, very, very stable. It's N2 molecule, and it's hard to break down, but that's part of the reason why there's so much of it. But it's neat that we are carbon, hydrogen, oxygen, now nitrogen, and in our atmosphere, carbon, dioxide, oxygen, nitrogen.
And oxygen's number 2. A lot of people don't know that.
You know what number 3 is?
I don't
You'll
know.
never know. It's argon, which is an inert gas that lives on the other side of the periodic table. Weird.
Okay,
Anyway,
so when you eat protein, it ends up in our mouth, in our stomach, an enzyme called pepsin starts to break it down to its constituent amino acids, and then in the small intestine, things like trypsin and chymotrypsin break it down more.
trypsin, that's the one that makes you fall.
Yeah. And because we can't absorb protein from our stomachs. A lot of
I
people
didn't
think,
even get a laugh from Hamza.
I know, he
Trypsin
nothing.
makes you fall.
I know,
He's asleep
nothing.
still. All right, fine. So.
So it breaks it down into our amino acids, because amino acids are what can be absorbed into our bloodstream, not protein. You don't absorb proteins.
No.
You absorb their constituent amino acids. We talked a little bit about this before. Some people talk about amino acids like they're Scrabble letters. There's a really great guy that's online, Chris Gardner, talks about this. Some people talk about it as kind of Lego pieces.
Yeah.
So some of them are bigger blocks, some of them are smaller, some of them are red, yellow. So they're all a little bit different, but they come together to make the protein
And
structure.
the cool thing is when you absorb them and as amino acids, your body can't tell where they came from.
That's right.
It doesn't know if it came from a plant, an animal, or the amino acid supplement that you took. It just
Right.
can't tell.
Right, so it ends up in your bloodstream, and what it does there is it goes to your liver. So amino acids only circulate in your bloodstream for 2 or 3 hours, actually. So it's a narrow window where your body's able to sense, hey, we have these amino acids present, we have this need, and that's to either make stuff, whether it's for muscle or neurotransmitters or whatever. So you can either synthesize stuff, you can convert it to the neurotransmitters or the hormones, or if there is no current need, it breaks it down. It removes the amine group, we pee that out, and then it uses that core for energy.
And stores it as fat.
There you go.
Or use it as energy. And so because these amino acids make up the infinite number of proteins that you can make up, there must be hundreds of these amino acids kicking around.
No, actually, Paul, there are 20.
20.
20.
So you're telling me that only 20 different amino acids can make up these millions of different proteins?
Essentially an infinite number, you're right. And like you had said before, their charges and the way that they're shaped kind of determines their three-dimensional structure, and that's what makes them unique, and that's why when you heat them or you digest them, they no longer work like the protein that they work.
Okay, and because we need to eat these amino acids to get them, that means that we can't make any amino acids. We must be required to eat all these amino acids.
I'm going to stop you right there, Paul.
Right.
So you're bringing up a really great point that someone's already typing in, saying, well, what's the difference between an essential and a non-essential amino acid?
Okay.
Okay, so great point. So there are 11 non-essential amino acids and 9 essentials. And what's the difference between essential and non-essential?
So essential amino acid means that your body can't make that amino acid on its own.
Right.
Non-essential amino acid means, hey, your body you don't have to eat that amino acid, but your body can make it.
Right, and like we talked about, so that's taking that carbon and the hydrogen, the carboxyl group, throwing an amine group on there, and then whatever side chain, it can make 11 of them.
So your body's pretty cool.
Pretty
if
good.
It can make these
Passing
amino
grade,
acids.
55%.
Right? That's all right. 5-0
and go.
5-0 and go. So I mean, you can make a good amount of these amino acids,
Right.
but not all of them.
Right, okay.
That's why you got to eat. Just like the primary producers, you can't make energy from the sun. Well, 9 of these things you can't make on your own, and you have to ingest.
Right, and so once your body ingests them, unfortunately it still can't store them, and this is the basis of needing regular protein intake on a daily basis, and the fact that they only circulate for 2 or 3 hours is why some people suggest that it's best to actually space out your protein intake over the day in 3 or 4 equal meals. There's some studies that target around the 25 to 30 gram mark, whether that's the maximum or not, that's a little bit debated, but spreading it out is better than one large meal because your body has a limited capacity in the moment to utilize them most efficiently.
Right, remember, it's going to take the excess at that moment or within a few hours, take off the nitrogen group, store the rest as energy back to your carbon, hydrogen, oxygens, and pee out the nitrogen.
Okay, so now they know about the protein. We
Do you
kind
though? Do you get it? Do you know what a protein is?
Because we
now?
talked about we're going to break it up in a bunch of different videos because people have different interests in what they really want to know and learn about.
Just remember the amino acids make up, and I call them amigo acids because they're like friends. They got to get together to make the proteins. That's what I used to say in high school. Amigo acids.
It's so bad. It's so bad. But now you know, if you're interested in protein or amino acids or have more questions, leave a comment. Let us know what you like about this, what you find more interesting, and we're going to do a follow-up video talking more specifically about different food sources, the RDA, and all that controversy. So if you like this video, please like it, subscribe to our channel, check out our podcast.
Are we done? That's it. That's all there is about protein.
Yeah, for now.
You are in charge of your own health.
We'll see you next time.